In this session, we'll be looking at the sign test, which is part of the inferential statistics taught in A-level psychology. Before we start looking at the sign test specifically, it would be useful for you to make sure you understand the key terms and language that crops up in this topic. So the terms that you need to be clear on are parametric data, design, level of data, difference data, relationship data, and inferential statistics. Where you see the pause symbol, feel free to pause the presentation so that you can complete the task and then check your answers on the following slide. So you can pause now to define these key terms. So the key terms, non-parametric data is not parametric data, which sounds a bit silly, but the criteria for data to be parametric is it must have homogeneity of variance. Now that means it has a similar dispersion, so range or standard deviation between the data sets. The data must be normally distributed, and this can also be called a bell-shaped curve, and it must be at least interval level data, which is the strongest level of data. If the data doesn't meet any of these criteria, then you use a non-parametric statistical test. Design is whether research uses matched pairs, independent groups, which can also be known as independent measures, or repeated measures data. The level of data is whether the data is at a nominal, ordinal, or interval level. Difference data, data which is looking to see if there is a difference between the conditions being tested or not. So are you getting the same or different results, or are you looking for the same or different results? Relationship data is data that's looking for a relationship between the two variables being tested and whether there is a relationship or not. Inferential statistics use a sample of data taken from a population to describe and make inferences about the population. In A-level psychology, you learn about the unrelated T, the related T, Pearson's, Spearman's, Mann-Whitney, Wilcoxon, Chi, and sign tests. You also learn about descriptive statistics, which provide a concise summary of data but don't go into as much depth as inferential statistics. You can summarise data either numerically or graphically using descriptive statistics, and the descriptive statistics taught in A-level psychology are measures of central tendency, the mean, mode and median, measures of dispersion, the range and standard deviation, and graphical representations, which include bar charts, scattergrams, histograms, line graphs, and frequency polygons. So when do you use the sign test? And there are criteria that your data needs to meet to use the sign test. Firstly, the data should be non-parametric. So it doesn't have homogeneity of variance, and/or it is not normally distributed, and/or it doesn't have at least interval level data. So if it doesn't meet any one of those three criteria, then you use a non-parametric test. You are testing to see if there is a difference between two or more conditions. The data is in separate categories, which makes it nominal data because you're counting up improvements, getting worse, or staying the same. And related data, matched pairs or repeated measures design, which means you cannot use independent groups or independent measures when doing the sign test. If you have independent groups data, then you use chi-squared. So, how do you calculate the sign test calculated value? And this is expected that you can do this in exam conditions. The clue is in the name. The sign test is all about the sign, and that is whether the data shows a positive or negative difference. We're going to look into that in more detail now. So data is often provided in a table like this. So you have improvement in score, or worse score, or no change in score with a repeated measures design. To link this to the sign, you need to give the values positive and negative signs. So if people improve in score, then you would give this a positive sign because they have improved. If people's scores have got worse, you give this a negative sign, and if there's no change in score, then we give this a 0. When calculating the sign test, we ignore the 0, the no change scores. So we are only looking at the positive and negative values. So to calculate the sign test calculated value, we need to look at those positive and negative scores. And you need to select the sign which occurs least often. In this case, the calculated sign test value is 4, because there are 4 negative values, and this is a smaller value than 15, which is the positive values. So now we want to look at other ways in which this data can be presented. It looks more complicated, but is a very simple calculation. So in this case, we've been provided with the test scores before the intervention and test scores after an intervention. We then need to calculate the difference between before and after, which I've done in the 4th column along. And then we need to give each of those values a sign, so if they've improved it's a positive, if they've got worse it's a negative, and if there's no change there's a 0. So in this case, the sign test calculated value is 2, because there are 2 negative values, signs I should say, in this data set, and 6 positive signs. Because 2 is smaller than 6, this becomes our sign test calculated value. So a quick test of your knowledge. A psychologist was interested in the influence of CBT treatment for OCD. He collected level of functioning scores before and after the treatment. The results can be found in Table 1 below. Your task is to identify the inferential statistical test you would use for this dataset and justify your choice in relation to this research. Then calculate the sign test calculated value for this dataset. You can pause the presentation now to carry out this task. The answers to that question then. The sign test is used because the data is non-parametric. There is not homogeneity of variance from the before scores, and they do not have a normal distribution. The data is testing for a difference in scores before and after the CBT treatment for OCD. It uses a repeated measures design because participants were tested before and after treatment, and the level of data is nominal because it is in categories of either improved, got worse or no change. Now notice how at each of those points I have justified my decision in relation specifically to this piece of research, not just generally said, oh, it's matched pairs design or repeated measures design. I have specified why in this case it is repeated measures design. The second question then, the calculated value for the sign test for this dataset is 3, because there are only 3 negative values and there are 5 positive values. I will show you on the next slide how I came up with those values. So I filled in the column the difference between before and after, and then I have filled in the sign column. Notice there are 5 positive values and 3 negative values. The sign test calculated value is always the smaller of these, and so in this case the calculated value is 3. Next, we need to know how to read a critical values table for the sign test, and you need to know how to read critical values tables for all statistical tests. For this one specifically we'll be looking at the sign test and the specific information you need to be able to read the sign test table. Notice underneath the table there is a sentence which says to be significant the calculated observed value must be equal to or less than the critical table value. Information will always be provided, and you need to make sure you read that information when you are analysing data. So, to read the critical values table we've just seen, you need to know whether the research uses a one-tailed or two-tailed test, the level of significance being used, and the n value. I'm going to run through those now. So the n value. This is calculated by adding together the number of positive values and the number of negative values in a dataset that you are analysing. In this case, there are 6 positive values and 2 negative values, so the calculated value of n is 8. Remember, we ignore the no change or 0 values. So a quick test of your knowledge. What would the calculated value of n be for this dataset? You can pause the presentation now to complete this task before you see the answers. So in this case, there are 5 positive values and 3 negative values, so the calculated value of n is 8. So a quick test of your knowledge, and in this case we're looking at whether the calculated value is significant or not. So a psychologist was interested in the influence of cognitive behavioural treatment for OCD, obsessive compulsive disorder. He collected level of functioning scores before and after the treatment. His hypothesis was directional. There will be a significant improvement in OCD functioning scores after CBT treatment has been provided than before the CBT treatment is provided. The calculated sign test value for his data was 8, and he used a significance level of p is smaller than or equal to 0.05. And this is the significance level that we always choose first in psychology. Remember, for the calculated value to be significant, it must be equal to or less than the critical table value. You can pause this presentation now to carry out that question and answer it before you see the answers on the next slide. So, the quick test answer. The results show that there is not a significant difference between OCD functioning scores before CBT treatment and after CBT treatment because the calculated value of 8, and that's the calculated sign test value of 8, is above the critical value of 1. Now I've shown you with the arrows and the red circle how I've got to that value. Because it is a one-tailed test and the significance level chosen is 0.05, I have gone from the 0.05 for the one-tailed test on the top row of the critical values table. We've previously calculated the n value as being 8, and so you'll notice the other arrow goes from the n value of 8 across. You join those two up and you get to a critical value of 1. Remember, you compare your calculated value to the critical value from the critical values table. And to be significant, the calculated or observed value must be equal to or less than the critical table value. In this case, 8 is bigger than 1, and so there is no significant difference between before and after treatment. Now, there are some very easy mistakes to make when looking at inferential statistics that mean you can get answers wrong without realising it because you've just mixed up numbers. So the first mistake that can be made is that you mix up the sign test calculated value and the n value. So when you calculate the sign test value, you calculate n and vice versa, which means you come up with the wrong value. So be really clear on the calculation of how to calculate the sign test result, which is the smaller of the signs, and the n value, which is adding up the two values of the signs. It's also possible to mix up the calculated value with the critical value, which means you can get the significance wrong. So make sure your calculated value is a value you've calculated from the dataset. Your critical value comes from the critical values table. And the final mistake that is often made is that students misread or don't read the sentence below the critical values table, which tells you if your calculated value should be equal to or below the critical value, which is the case for the sign test, or equal to or above the critical value, which is the case for some of the other statistical tests in psychology. Hopefully that's helped you clear up the sign test. Thank you for listening.